Okay, welcome to your first math AMS of the year. أكيد last week was diagnostic فيعني رواق. Okay, this week عندك combinations، عندك السيجما، عندك الفactorials. Everyone here knows sigma. Okay, I'm gonna start with factorials. Okay, x factorial is defined. Okay, you can do all of this on the calculator. I'm telling you, every single question here, you can do it on the calculator. But starting next week, in the following weeks, and I think most periodics, I think our first periodic command, it will be non-calculator. Okay, because you can do everything on a calculator, and so there's no point of the exam if you can just put the question on the calculator. Anyway, I'm gonna explain. So when you get the non-calculator, you won't be lost. X factorial is defined as the product of all numbers starting from all positive integers starting from 1 up until x. So it's the product of all numbers from 1 until x. For example, 4 factorial is equal to 1 times 2 times 3 times 4. 7 factorial is equal to 1 times 2 times 3 times 4 times 5 times 6 times 7. Walid, what's the point of factorial? You're gonna need factorial for the combinations, okay? But before we get to combinations, I'm gonna teach you how you can cancel with factorials. Let's, for example, I'm gonna start off with x factorial divided by y factorial. It's very important that you know x factorial over y factorial does not equal x divided by y factorial. Okay, this is a common mistake many students make. For example, بيشوفوا 8 factorial over 2 factorial وبيحطوا 4 factorial. This is completely wrong. Okay, don't do it. I'm not going to explain why. I think it's pretty obvious why. Let's start by how to cancel factorials. Okay, to cancel factorials, there's a trick. Okay, let's say you have 15 factorial, okay, over 10 factorial. Okay, whenever you have a fraction involving 2 factorials, it's very important. Okay, it's very important. Here's a step. You choose, I'm gonna give you 2 steps. Choose the 2 largest. In this case, 2 largest numbers, okay. In this case, it's only 2 numbers, okay, so it doesn't really matter. But in other cases, I'll give you an example after this where it's 3 numbers or 4 numbers maybe. After you choose the 2 largest numbers, you're gonna rewrite, or you could say expand or rewrite the largest number in terms of the second largest number. Okay, and then step 3, cancel. Let's apply the steps. 15 factorial over 10 factorial. My 2 largest numbers is always 15 and 10. The second step is to rewrite the largest number in terms of the second. Before following steps 2 and 3, I'm going to explain what I'm about to do. I'm going to show you the normal way. The normal way to rewrite 15 factorial in terms of 10 factorial is to change 15 factorial into 10 factorial times 11 times 12 times 13 times 14 times 15 over 10 factorial. And then I would cancel 10 factorial with 10 factorial. I'll be left with these as my answer. طب وليد, what did you just do? Let me explain. Isn't 15 factorial 15 factorial is equal to 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10 times 11 times 12 times 13 times 14 times 15. Okay, I wrote the whole thing just so I can help you understand. But let's say I wanted to take here 1 times 2 times 3 times 4 times 5 times 6 times 7. Isn't this the same as saying 7 factorial? Right? It's the same as saying 7 factorial. So 15 factorial can be written as 7 factorial times 8 times 9 times 10 times 11 times 12 times 13 times 14 times 15. Okay, you know what? Let's say I don't want 7 factorial. Let's say I want 3 factorial. Would that work as well? Yes, of course it would work. Let's say you take 1 times 2 times 3. Isn't that the same as 3 factorial? Yes, 3 factorial times 4 times 5 times 6 times until you reach 15, right? These are all equal. Okay, how about I write it in terms of 12 factorial? Again, 12 factorial would be all numbers from 1 until 12, right? 12 factorial times 13 times 14 times 15. These two are equal to each other. Okay, so it's very important you understand why I'm doing this. So هلا in our 15 factorial over 10 factorial example, 15 factorial, isn't it equal to 10 factorial times 11 times 12 times 13 times 14 times 15? Yes, so you could say 15 factorial is also equal to 10 factorial times 11 times 12 times 13 times 14 times 15. So I can rewrite this over here as this: 10 factorial times 11 times 12 times 13 times 14 times 15 over 10 factorial. هلا can I cancel? Yes, this with this. You'll be left with 11 times 12 times 13 times 14 times 15. Okay, so instead of all this yap, I'll give you a quick way. Anytime you see 2 factorials and you want to cancel, you know you're going to cancel. The bigger factorial, sometimes the bigger, what if it's 10 factorial or 15 factorial? Does anything change? No. Same way of solving. It will change to 10 factorial over 10 factorial, 10 factorial here, times 11 times 12, again, until you reach 15. Then you cancel this with this until you reach 15. And you cancel this with this, you're going to be left with 1 over this. So it doesn't change if it's the other way around. But how can you do it in a quick way? So quickly, so your brain gets used to it. The bigger number, quickly change it to the other factorial half. So 15 factorial, quickly write down 10 factorial, change it to 10 factorial. Then what numbers come after 10 until I reach 15? Quickly, what comes after 10? 11, 12, 13, 14, 15. This is how you quickly do it, okay? That's how you quickly rewrite factorials. I'm gonna start. Okay, they want combinations. Okay, we're done now. You know what a factorial is. I'm gonna tell you about combinations. Combinations are denoted by NR. This is the combination of NCR. You call this also NCR. These are the two names for combinations. Combinations are defined by choosing a combination of choosing R combinations from a set of N objects, right? Selecting, combining R objects from a set of N objects. So you would want to select, let's say you have 10 students and you want to select 3 out of the 10 students, 3 out of the 10. N is always your total, so 3 out of the 10, you would be 10C3. This is how you'd write 10C3. Okay, this combination has a formula. NCR is equal to N factorial over R factorial, N minus R factorial. This formula, you can memorize it. It can also be done on a calculator, but this formula, you must know it. Okay? أكيد وليد, if they let you use calculator, do we have to memorize the formula? أكيد no. أكيد if you use the calculator, see here, if you press 10, you want 10C3, you press shift and then divide, you get C. You press 3, you get 120. So this is just to solve this one over here. Listen, in my opinion, the regional any day, any time could switch up and say, you know what, I don't want to give them a calculator on whenever Thursday, we have AMS Thursday, and all of a sudden we don't have we don't have calculators. So my advice to you, memorize I'm recording this a week before the CA, so I don't know, but if she switches up suddenly, you must memorize the formula for this, and you must memorize how to do factorials over here, okay? Because everything here can be done on a calculator. Where did I go? Okay, so also combinations can also be equal. So NCR can be equal to N, instead of calling it R, I'll call it A. NCA can be equal to NCB if A plus B equals N. Walid, what do you mean? Okay, let's say I have 10C6 and 10C4. Are they equal? Yes, they are, because 6 plus 4 equals 10. Okay, how about 10C3 and 10C4? Are they equal? Of course not. 3 plus 4 does not equal 10, so they are not equal. Okay, so let's see here. The number of different ways of selecting R objects from a set of N objects is denoted by NCR. Which of the following is true? Is 64 equal to 62? Yes, because 4 plus 2 equals 6. Is this equal? Yes, because 4 plus 6 equals 10. Are these equal? And I have 6 and I have 6. Oh, actually, they don't add up. Potentially, these two are different. Here, 6 plus 1 is 7. It doesn't add up to 6, so it's wrong. Here, 4 plus 6 is 10. It doesn't add up to whatever you have here. Question 2. Okay. هلا sigma. I'm sure most of you know what sigma is. I think you all know what the sigma notation is. But we'll go over it quickly again. Sigma means sum. Okay, you add up. So it could be, I'll give you quickly some rules about the sigma. Let's say it starts from k equals 0 until n. Okay, and sigma of any number, you could say I. Okay, it just means to add up. Let's say I want to do sigma k from k, if k starts at 0 and it ends at 5. This would be same as saying k starts at 0, so 0, then it goes to 1, then it goes to 2, then it goes to 3, goes to 4, until it reaches 5. And then sigma means you add them up. That's why I put these pluses. Okay? And whatever you get here, 5, 10, you get 15. That is what sigma means. Okay, let's say I had sigma. There are a few rules you must memorize, akid, if you don't have a calculator. The sigma of any number I, okay, I equals 0 until n, it will be equal to n plus 1 over 2. And the sigma of I squared, I starts at 0 until n, is n plus 1 2n plus 1 over 6. These two, if you had non-calculator, you must memorize. Okay, you can solve without it, but it will be very hard. It will take you a long time. Thinking of other, also with sigma, you have the distributive property and you have the distributive, and I forgot the other one what it's called, but I'll show you what it is. Let's say I have sigma of 2k. It's the same as saying 2 sigma k, but that's not sigma. You just take the 2 outside. Okay, let's say I had sigma x minus y, right? It's the same as saying sigma x minus sigma y. Okay, these are just quick rules about the sigma. Over here, sigma I squared, I starts at 1 and it ends at 5. So obviously it will be 1 squared, then it goes what to 2, so 2 squared, then I becomes 3, so 3 squared, until we reach 5. So it's going to be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared. Question 3. What is the value of 0 factorial plus 6 factorial? Okay, before going to question 3, I'm going to show you that you can do this on the calculator. Most calculators have this. Mine doesn't, because it's old and I really need a new calculator. Inshallah, I will buy one. Make sure, by the way, that if you are buying any new calculator, make sure it does not have the integral sign, because soon enough, in a few weeks, in I say 4 or 5 weeks, you will not be allowed to use the integral calculator. Okay, this symbol over here, make sure you don't have it. Anyway, sigma, you put here x squared. It doesn't have to be the same letter. X squared. It can be x, as long as it's a variable. Then you go down, starts at what? At 1, right? 1, and then it goes up until 5. 50. Oh wait, no, this is okay. This is different for this. If you add these up, you get 55, but they're not asking for the answer. They're asking for something else. Okay, you have to use the way I showed you. Here, you can use the calculator. 0 factorial plus 6 factorial. It's important to know that 0 factorial equals 1. Okay, and 6 factorial, I'm not asking you to find it. Oh, why did I open Spotify? 6 factorial, you can do it on a calculator. Look, 0 factorial. So to find factorial, press shift and you press on this x here. Okay, plus 6 factorial, and you get 721. 6 factorial, I'm not going to ask you to solve it on paper, but it's 720. Okay, here they're saying if 120 times 119 times 118 times 117 equals p factorial over q factorial, then what is p and what is q? So they divided p factorial by q factorial, and they got the answer is 120 times 119 times 118 times 117. Okay, if you get a question like this, remember we're working with factorials. So at the start, before they cancelled, okay, we want to know what they had before they cancelled. We want to know what these P and Q are. We know before they cancelled, it was a factorial, right? So that means before they cancelled, the factorials, factorial reaches 1. So if we kept on multiplying until we reached 1, right? Okay, what is our biggest number here? Remember when we used to cancel 5 factorial over 3 factorial, for example, we would rewrite the bigger one in terms of the smaller one. So 5 factorial will turn into 3 factorial. Then what comes after 5? What comes after 3? 4 times 5 over 3 factorial. You cancel, you get 4 times 5, right? Isn't the biggest number here the same as the one that's under the factorial? Yes, of course, yes. So, akid, my biggest number here, 120, is the same as this factorial. So this P was 120 factorial. Hello, we just need to find the Q. What was the Q? Very easy. Nihna, we stopped over here at 117. Let's look at our example of 5 factorial divided by 3 factorial. The number we stopped at is 4. Okay, what was before the 4? It was 3 factorial, right? And isn't that 3 factorial what is down here? Yeah. So now, since we stopped at 117, the thing that's after, or you could say before, it doesn't really matter, or it doesn't matter, that came before this 117, it got cancelled. Why did it get cancelled? Because that was the factorial that was in the denominator. And what comes before 117? Obviously, what was here was 116 factorial. Okay, so this Q factorial will be 116 factorial. So 120 and 116. Okay. Question 5. The other one you couldn't do it on the calculator. This one you can do it on the calculator, but let's not do it on the calculator. So let's explain it. 21 factorial over 19 factorial. What's the first step? First step, quickly, anytime you see these, the first one, write it and change it to the factorial that's smaller. What's the smaller one? 19. So 19 factorial. Okay, what's left? What comes after 19 to get 21? 20, 21. And then write the 19 factorial down. Cancel. You're going to be 20 times 21, 420. Or you can just do this. You can just do 21 factorial over 19 factorial, 420. Question 6, what's the value of 10c6? Again, you can use the formula n factorial over r factorial, n minus r factorial, and you're going to get 10 factorial over 6 factorial, 10 minus 6 factorial. But again, these are very large numbers, so I wouldn't expect you to be able to solve them without a calculator, because 10 factorial, look, 10 factorial is, imagine having to multiply 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. You get this number. So I'm not expecting you to solve this. But you can solve it on paper. Hell, I'll show you. But anyway, let me show you. 10 factorial over 10 factorial. I can show you. Or no, you don't even have to write this down. You can just write 10c6. These combinations, remember, you can just write 10 shift divide to get the c6. See 10c6, 210. But if you were to solve this on paper, okay, you can simplify this. 10 factorial, okay, over 6 factorial. 10 minus 6 is 4, so 4 factorial. So in my denominator, I have these 3. Remember when I told you sometimes you're going to have 3 numbers? So it doesn't matter. Always pick the biggest 2. So my biggest 2 are 10 and 6. So I'm going to rewrite the biggest one in terms of the second biggest one. So 10 factorial, I'll change it to 6 factorial. Then what comes after 6 factorial to get me 10? 7, 8, 9, 10 over 6 factorial, 4 factorial. 6 with 6, you're going to be left with 7 times 8 times 9 times 10 over 4 factorial. What is 4 factorial? It's 1 times 2 times 3 times 4. Can you simplify this? Yes, you can. Okay, you can divide 8 by 4. You can get 2 up here. You can cancel this 2 with the 2. You can simplify this 9 with the 3. You can get 3 here. So now this is very easy to solve on paper. 7 times 3 times 10, which also gets you 210, in case you had to solve it on paper. Okay. Question 7. Okay, if sigma ci is 20, then what is the value of sigma 10 ci? Okay, what did we say when we have a constant? Can't we just take it out? Yes, we can. So it's the same as saying 10 sigma Ci. And we know that sigma, I'm not going to write the 100 and I equal 1. You get me. I'm not going to write these. Okay, what do we say sigma Ci is? It's given that it's 20. So 10 times 20 is 200. You don't need a calculator for this. I think even grade 6 can solve this. Question 8. What is the value? Okay, yeah, I didn't explain this, but whenever you have sigma of x, okay, let's say x is any number. Okay, x is any positive integer. Let's say positive integer. Okay, and it starts at, let's say, whatever, I equals 1 until 100. Okay, this is the answer of this will always be, or instead of 100 I'll say n, goes up to n. The answer of this will always be x times n. What do I mean? What is sigma? It starts at 1. Yeah. What is sigma I equal 1 until 50 of let's say 7? Very easy. You're adding 7 50 times, right? So it's going to be equal to 350. 7 times 50. So here, instead of doing 2 plus 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 2 100 times, you can just do 2 times 100 and you'll get 200. Okay. 9. Okay, here very easy. We have sigma p is 25, sigma q is 30, sigma r is 10. What is sigma p plus q minus r? Okay, we know the distributive property or whatever. We can split these up, right? We can split this up into sigma p plus sigma q minus sigma r. And we know that sigma p is 25, sigma q is 30, و sigma r is 10. ما في أسهل من هيك, and you get 45. Just solve this. Question 10. Okay, this you can do it in the calculator, but I will show you, I'll show you my way. Okay, let's start. What most people do, they take out 2i. And when I take things out, I only like to take numbers out. I don't like to take letters out. Okay, so here I'm gonna take the 2 out. Okay, I'm gonna keep I inside, I plus 1. This is if you're solving on paper. I'll show you how to do it in a calculator. You can skip if you want. I equals 1, 6. What do I do from here? And I distribute the I inside. Okay, I'm gonna get 2 I squared plus I. Okay, up until 6. And I equals 1. So you can do this, you can substitute I with 1 and then 2, then 3, then 4, then 5, then 6. Or you can simply use the rules we have here. Sigma of I is n plus 1 over 2, or sigma I squared n plus 1 to n plus 1 over 6. And I'm going to use the rules, okay? I'm going to use the fact that sigma I is n plus 1 over 2, and sigma I squared is n plus 1, 2n plus 1 over 6. So let's start with here. Can't we split this up into 2 times sigma I squared plus sigma I? We can, صح? So we can just we know it goes up until 6. So we know our n is 6. So for sigma I squared, let's just substitute n with 6. It's gonna be 6 plus 1, 2 times 6, which is just 12, plus 1 over 6. Okay, and then for sigma I, substitute n with 6 again. It will be n plus 1 over 2. So plus n plus 1 over 2 will be 6 plus 1 over 2. You can do this. If it's on paper, you can cancel 6 with 6 directly. Okay, you're going to get 7 plus 1 times 12 plus 1, which is 7 times 13, which is 91. Plus, here you can cancel 6 with 2, it will be 3. 6 plus 1 is 7. 7 times 3 is 21. Then you have this 2 outside. You're going to get 2 times 91 plus 21 is 112. 2 times 112 is 224. So this is if you want to do it on paper. Okay, if not, it takes you maybe 15 seconds on the calculator. Let's see. Sigma. Okay. Over here. Sigma. 2. Remember, always the letters, write them as x. The calculator doesn't understand it. 2x, right? And then open the brackets again. Okay, even though they wrote brackets for you already, you have to open the brackets again. X plus 1. and make sure to close the brackets because the calculator will not understand unless you close the bracket you opened. Okay, then down نحط 1 وفوق بنحط 6 ولا في أسهل من هيك 224. But أنا of course I recommend to do the calculator method. But if I'm solving non-calculator method كمان, in case they give you that calculators are not allowed, because my teacher mentioned that this year they will be doing AMSs and periodics without calculator. Here, same thing, you can do it in the calculator, or like I did أنا, similar to the last question, sigma I to I plus 1. I distributed the I inside, okay, because I don't like to take letters outside. I like to distribute. Okay, I equals 1, 4. Okay, but here, sigma 2I squared plus I from I equals 1 and 4. Okay, over here, you can split this up into sigma 2I squared, okay, plus sigma I. And we know we can take this 2 out here, so it will be 2 sigma I squared plus sigma I, okay, and then it goes up until 4. We know that sigma I squared is n plus 1, 2n plus 1 over 6, sigma I is n plus 1 over 2. So here, for sigma I squared, let's substitute n with 4, right? So it will be 4, 4 plus 1, 2 times 4, so 8 plus 1 over 6, plus sigma I, we know sigma I is n plus 1 over 2, so sigma I, we can substitute n with 4, so it will be 4, this is a 4 over here, no? 4 plus 1 over 2. We can solve this on paper, cancel this with this, you get 2, 4 plus 1 is 5, so 5 times 2, 10. Okay, and then over here, you can cancel this with this, it comes 3. We can simplify this 4 plus 1 is 5, 8 plus 1 is 9, and you have this 3 down, cancel 9 with 3, you can get 3. Then this is really simple multiplication, 4 times 5, 20, 20 times 3, 60, you get 60 plus 10, you get 70. Again, Walid, can you solve this on the calculator? Yes, you can. Shift, log, you get the sigma. I is outside, so remember, keep I as x, open the brackets, 2x plus 1, close the brackets, go down, x starts at 1, up until 4, 70. Thank you so much for watching. Make sure in case to check with if anybody is in Sabis Khalifa and you're watching this, please make sure to check with the regional, ask her if it will be calculator or non-calculator. Thank you so much for watching, and good luck.